Hello and welcome to Connor's Chemistry. The idea is we'll pick a range of questions, we'll deconstruct them, think about the knowledge that's needed to answer them, and then have a go at answering them. So first question, I'm going to start off quite easy, is all about structure and bonding. Okay, so when we're thinking about structure and bonding, there are three types of bonding. They are ionic, between metals and non-metals. They are covalent, between non-metals. And then we have metallic bonding between different metals. These are the three main ones that you need to remember for your exam and be able to talk about each and every one. So we look at the question. Figure 1 shows one part of a layer of graphene. Okay, so instantly you should be thinking, right, graphene is made of carbon. It's only made of carbon atoms, which must mean, as it's a non-metal, it must be covalently bonded. So we look at the question. We've got a nice diagram of atoms, all of carbon. We then look at the question, worth 1 mark. Which element is graphene made from? So already, because we've kind of annotated it and shown what we know it is carbon. That would instantly get us 1 mark in our exam, off to a very strong start. Second part of the question. Each atom in graphene has one delocalized electron. Now, delocalized is just a scientific word for a free electron able to move. We should know that an electron has a negative charge and is able to move freely. So we are completing the very easy sentence. Choose the answer from the box. Act as a lubricant, be used as a fuel, conduct electricity, dissolve in water. So, delocalized electrons allow graphene to. Now, it's not going to be anything about a lubricant because we're talking about these electrons that are allowed to move freely. Okay? We're not going to be worried about using them as a fuel. It's nothing to do with dissolving in water. The one thing, because we have moving electrons, is going to be able to conduct electricity. Moving electrons are electricity. So again, we've got a nice easy mark. The next question, when it comes into focus, is which structure is a fullerene? Tick 1 box. So if we think of a fullerene, we know that a fullerene is again something made from carbon atoms. So if we look at these structures, this structure is more like a diamond in terms of every carbon being bonded to many others. This is oxygen and hydrogen, so we know it's definitely not on this one, so we're just going to cross the answer out. This would be more covalent bonding. We've got metals and non-metals and ionic bonding, so it's not going to be this one. So we've got a choice between two. Now a fullerene is more like in these kind of tubular-like structures. So we're going to have this as our answer, and again, a nice easy mark. The last part of this question then changes slightly into hydrocarbons. Now, as soon as we see that word hydrocarbons, we're identifying the hydro and the carbon part, meaning one element they're made from is hydrogen and the other is carbon. This shows us a type of polymer. Poly meaning many. This number suggests that because n can be any number. Nice easy question then, worth 2 marks. So there's quite a few marks available. Which 2 elements are in all hydrocarbons? So as we've already deconstructed our question, we know already. Oh, that's me getting it wrong. Hydrogen and carbon. 2 easy marks for us then to add to our total. Choose the answer from the box. The large molecule represented in figure 2, so back to our diagram, is an atom. It's definitely not an atom. It's definitely not a metal because we've got non-metals in there, so we know it's definitely not this one. We know it's a polymer because we've identified that from our picture already, and it's definitely not a salt, so we know it must be a polymer because we've deconstructed our question and we know already. Again, guaranteeing ourselves a mark. Last part of this question then, complete the sentence, choose the answer from the box. Metals can be stretched into wires because the layers of atoms can. So when we're putting things into long wires, it must mean we're able them to move, they can slide, they can kind of move around each other. So it's nothing to do with attracting. Okay, it's nothing to do with they can bond. We don't want them to bond. We've got this word slide as our best option so far. Vibrate. All atoms vibrate anyway. Okay, so we're going with slide because they can slide next to each other. Again, guaranteeing ourselves a mark, and 7 out of 7. First question will be slightly easier, but this is our key knowledge we need to be able to do. We need to be able to identify what the structure is, the types of bonding, and obviously the elements contained in those structures.